Unit 4, Lesson 5, Pythagorean Theorem and its converse. What is the Pythagorean Theorem? The Pythagorean Theorem says, in a right triangle, the sum of the squares of the legs is equal to the square of the length of the hypotenuse. What the heck does that mean? In an if-then statement, it says, if a triangle is a right triangle, then leg squared plus leg squared equals the hypotenuse squared. We know the legs to be A and the other leg to be B, and the hypotenuse is always C. Its converse is the same but backwards. This says if the square of the length of one side of a triangle is equal to the sum of the squares of the lengths of the other two sides, then the triangle is a right triangle. Basically, if leg squared plus leg squared equals hypotenuse squared, then the triangle is a right triangle. So if you do the work and you find out that a squared plus b squared does truly equal c squared, then you are for certain that you're dealing with a right triangle. What is a Pythagorean triple? Pythagorean triples are, think back to all of the times you've done Pythagorean theorem. A lot of times you get whole numbers and a lot of times you get decimals. The Pythagorean triples are the ones where you start out with whole numbers and you get whole numbers. These are your nice ones. So it's a set of non-zero whole numbers, so really integers, or I'm sorry, really natural numbers, where A, B, and C satisfy the equation. So if you were to take something that's the length of 3, something that's length of 4 and 5, 3 squared plus 4 squared equals 5 squared. It's a Pythagorean triple because each number is nice, non-decimal, non-zero. If you were to do 5, 12, 13, 5 squared plus 12 squared equals 13 squared. Pythagorean triples are those nice answers where you won't have to round. So here's a problem. It says a right triangle has a hypotenuse length of 25 and a leg length of 10. Find the length of the third leg. Draw it. Hypotenuse. The hypotenuse, by definition, is always directly across from the 90-degree angle. So there's your 25. And then it says it has a leg length of 10. Whether you put the 10 here or whether you put the 10 here doesn't really matter if you're sketching, as long as it's on one of the legs. Go ahead and set up the problem. I want to know what is the other side. X squared plus 10 squared equals 25 squared. So the leg squared plus the leg squared needs to equal the hypotenuse squared. Go ahead. Actually, I'll go ahead and do it. So x squared, 10 squared is 100. 25 squared is 625. Get x by itself, we've got to move the 100. We end up with x squared equals 525. But I don't want x squared, I want just plain old x. To undo a square, you will square root. It cancels that out. X ends up equaling, I think I rounded, must have rounded to the nearest tenth, 22.9. It says, do the lengths form a Pythagorean triple? In this case, no. Even though 10 and 25 are nice numbers, 22.9 isn't. It doesn't make it wrong. It just doesn't make it a Pythagorean triple. Use the converse of the Pythagorean theorem to decide if the lengths form a right triangle. Be careful when you do these problems. When you talk about your A, your B, and your C, whatever is the largest, or I should probably say the longest side, is your C. they can be ordered in any way you want them to be, but recognizing that whatever is the longest is really what's going to be your hypotenuse. So I'm going to go take this problem out here. So 13, 84, and 85. The longest leg is the 85, so that's your C or the hypotenuse. 13 squared plus 84 squared. I want to know, does it equal 85 squared? If it does, it's a right triangle. If it doesn't, then it isn't. So 13 squared gives me 169. 84 squared, I don't know. I didn't show that when I did my work, sorry. So whatever that is. But when I ended up adding them together, I got 7,225 and 7,225. So 85 squared, those two things added together squared. Yes, they equal each other, so that means they must have come from a right triangle. And if you think about the idea of Pythagorean triple, those are three nice numbers. So not only are they a right angle, but they are a Pythagorean triple. Go ahead and try letter B on your own. Please just be aware that which side is the longest so you know where to put it. All right, so I want to take just a quick second. This is my answer key for the activity that you did, I don't even know which day it was, the other day. And I know my page is always a little bit messier than yours, but the purpose of this exploration was for you to play around with the Pythagorean theorem. So at first I asked you to use only 90 degrees. I chose examples where A was shorter in one, so I guess this one A was shorter. Here my A was longer, so I just messed around with side lengths. Not the biggest deal, it doesn't matter. But if you were to put in an A, a B, and a C, C squared equaled those two squared every time. And you had to do a little bit of rounding. That's the Pythagorean theorem. But the other thing that we want to know is the converse says that if it doesn't work, then it's not a right triangle. Well, what is it? So let me show you that slide real quick. So it says if a triangle is not a right triangle, it can be either acute or obtuse. And the Pythagorean theorem can tell us that. What I'm hoping you discovered in that exploration was that when you had an acute angle, the C squared column was always less than the sum of the squares of the other legs. When you had an obtuse angle, so whatever angle you wanted to, whatever side lengths you wanted to, the C squared was always larger than A squared plus B squared. So the if-then statements you can make, the one for a right angle is the Pythagorean theorem. If a triangle is a right triangle, then C squared equals A squared plus B squared. I know I kind of reversed it. We can do that with an equation. In an acute angle, if a triangle is acute, then we recognize every single time that instead of an equals, it was less than. And if we did it for an obtuse, every time we did it, C squared was greater than A squared plus B squared. So that's all I'm going to put over here on this slide. C squared every time was less than A squared plus B squared. So you can't necessarily tell what the triangle, whether it's a 30-degree angle or a 45-degree angle. All you know is that it's not a 90-degree angle. And then for obtuse, then, C squared, every single time you did that, it was larger than the other two. Try these. Classify the triangle as either right, acute, or obtuse. So 14 is my largest, so I'm going to go ahead and call it my C. I'm going to start out with C squared. I'm going to leave a blank, and I need to put in my A squared and my B squared. 14 squared is 196. A squared is 36, B squared is 121. So that's going to give me 196 and 157. Because 196 is larger than 157, I can determine that this is obtuse. Try it here. It is a Pythagorean triple. It's going to work out. You may start recognizing them. A, B, C. I'm calling that C because it's the longest. 13 squared, blank. The other two, 169. And all I'm doing is the calculation straight down. 169 is blank, 169. Because they're equal to each other, I know that this is a right triangle. Go ahead and try letter C. We will go over the notes in class so you have a chance to ask questions, and then in class you will do the worksheet. Thank you.